हमारे अक्षर तो भाई
अक्षर ओ पूरा भी नहीं सुनता मुझे लिख रही मारा तो लिखना पड़ता है वॉल्यूम मैक्स
ये सब
बट हमें तो नहीं
बेटा फ्री बता पेन लिख वॉल्यूम
पेन रिलीज
बेटे का क्या फ्री मार टॉपिकल एंड स्पिललेस
नैनो
नहीं आई एम नॉट
इससे बेटर बता
इससे बेटर है
पागल है भाई वॉल्यूम सबसे बेटर है
नहीं देखो सच में सर्च कर तो गूगल BENG के बाद
भाई सबसे ज्यादा
पिंक कलर का क्यों बोलते हैं
मूवी में करना होता भाई
अबे तो
मुड़ाते
वही
रहते
अच्छा
अच्छा बनना
बोले कोई बोला बस इजी चुका बस उसको एडजस्ट करके अपने स्टाइल में जैसे मैं बोलता हूँ और कैसे एकदम फन स्टाइल में और किसी को बोलने भी नहीं करते मालूम ये ज्यादा सही है
मूवी भाई अलग इंसान है चांद
स्कूल बोल जाता रहता है
स्कूल भाई
उस दिन गए थे यार मैं
भाई 4 लोग ही थे और मुझे डांट रही
ओ
डांटेंगे ना 6:30 आएगा और 5:50 5:45 ले गए थे 6:30
या तो पूरा बता या तो ऐसे बोल दिया नहीं कर
सबसे भैया वो ग्रुप है नहीं मोड़ी का आवाज नहीं करता भैया
ये बारिश हो गई गाइस
आवाज सुन रहा है
उनके एग्जाम्स होने हैं
वो भाई बस
दिन में
मैं डांडी कर रहा हूँ पार्टी 10 से पिज्जो पार्टी नहीं है ना पिज्जो पार्टी
नहीं दिया भाई
मेरे को 2 बार कैंसिल नहीं किया
मेरे को तो देना ही है
अबे मैंने बोला भी था
नहीं मेरी मम्मी ने
मैं तो बोला चाह रही
वो ले लिया
क्यों पार्टी के दिन
तूने टफ क्या कर रहा है कुछ बताते हैं आज नहीं कुछ करना ही
देखो तो बुलाएंगे
करना आंसर मिल जाता
नहीं किसी को नहीं बुलाया
कितना क्या
आज नाम पढ़ाएंगे
तो आज पार्टी
है
लेगा ना
रिकॉल यार रिकॉल
ए आज हमको पढ़ना पड़ेगा
हां
so you should understand and apply
और बुलाने तो बहुत लाता ही है आज हम सबको चाहिए
अच्छा ये
विराट करेगा पार्टी
resistance
दिलाने
arch meter length radius 5 cm
अबे इधर समझ ये छोटा फ्रेंड्स
क्या चक्कर
हाँ तो
आधी पार्टी लेगा
उसको करा दो मैं क्लास में
7
तो टेस्ट क्यों नहीं आया
आज के सारे
इसे तेरे बैग में दे दो पेपर
मैंने बोला भी था
हम सबको
बोला
From the open
इसको एनवायरनमेंट में टाइमिंग बता दो मैंने तो 6 बजे बोला भी था एक्चुअली बोला तो मैं बस ऐसा भाई मैं एक्चुअली आज तक डाल दिया 300 रुपए के बाद मम्मी
नहीं बट आगे
ये एक्चुअली ट्राई करना था ऑनेस्टली अच्छा है क्या
अरे फर्स्ट टाइम तो फ्री है नाइट में
हां
आसपास
ये एक्चुअली मैंने देखा नहीं सर
अक्षर के सारे
अब ठीक हो सकता अब इस फोन पर नहीं है
मैंने तो बिगड़ता है बेटा चलिए
बच्चे के बाद मैंने देखा इसका पानी पानी
तो उसके बाद मजा आया
यस
नहीं आदित्य से मजा आया
इसके बाद
ये एक क्लास हुआ आज सर ने पूछ लिया
भाई आज लिटरली कुछ नहीं हुआ भाई क्लास में
मैं आदि आज सर ने पूछ लिया पेरेंट्स आए क्या
तो अगर तो बर्थडे 15 अगस्त को था
वो इधर पेरेंट्स आए क्या
मेरे नाना जी का बर्थडे भी 15 अगस्त को
तो गया था
ओए अंकल पेरेंट्स लाए तू
सुअर का
अबे उनको टाइम नहीं है मैंने ऐसा बोला ना मैंने स्वागत का बोला उसके बाद मैंने बोला कि क्या
बोले क्या है वो
ऐसा
अरे क्या
गाली ने गाली ने केक दिया
अरे पेरेंट्स लाए
उसके बैटरी से
Dedicated to the course, not by choice.
नहीं सर वो डेडिकेटेड में चॉइस है
आदि ने
अब
स्कूल में करवाया था 500 में
किसका? ये वाला?
नहीं 13 क्वेश्चन
नीचे दिया हो
स्टेटमेंट 1 करेक्ट है दूसरा नहीं था
Given that resistivity of gold and platinum is this, किसका ज्यादा है? प्लैटिनम का, है ना?
स्टेटमेंट 1 करेक्ट है
So 5 meter of platinum wire will have same resistance as 1 meter of gold wire. Okay.
तो वो करेक्ट
पर
है
ये सही है बीटी से होगा
Gold wire of 1 centimeter radius will have the same resistance as platinum wire of 5 centimeter radius. So निकाल कैलकुलेट करके देखो ना, कैलकुलेट करके देखो.
मेरा ए सही है ए सही है तो बी भी सही होगा
ये तो ठीक है,
Ratios में
ये तो 2 into 5 करोगे कितना है?
5 करेंगे सर 10
Same ही आ गया ना. 5 meters of platinum wire will have the same resistance as 1 meter of gold wire.
तो वो करेक्ट है वो
तो सेकंड वाला भी सर सही होगा ना कुछ वो रेशियो होगा तो minus 2 5
नहीं जब कैलकुलेट करना पहले एक मिनट. रेजिस्टिविटी क्या फॉर्मूला है रेजिस्टेंस का?
R is equals to specific
रो L by A. A कांस्टेंट है, ठीक है? So what is
constant
हाँ
सर A नहीं है constant L constant
नहीं फर्स्ट में क्या है? 5 meters of
सर
platinum.
फर्स्ट नाम होगा आपसे
कैसे हो गया फर्स्ट वाला? बता ना मेरे को. ये प्लेटिनम है और ये क्या है?
गोल्ड का है
गोल्ड का है. गोल्ड का कितना है?
5 times होगा
ये
पेपर दिया सर
और
L constant
ठीक है. एक ये निकाल दो चलो. रेशियो ले लो. RG कितना है? 2.8. कैसे आएगा सेम?
तो सेम 2.1 into 5
2.1 into 5 किधर है?
5 platinum
गोल्ड का कितना होगा?
platinum का 2.1 so platinum
हाँ, तो फिर वही मैं बोल रहा हूँ कब से इसको.
10.5
This is how you will be optically fooled. So do not rely on your brain, rely on calculation.
आज कैलकुलेट
ये सिली मिस्टेक होती है फिर फास्ट जाने में, तो गलत हो गया ना. 5 meter of platinum oil, platinum first वाला wrong हो गया ना. And only statement B is correct. Okay. A gold wire of 1 centimeter radius will have same resistance as platinum. Now take L constant. ठीक है. So gold wire का क्या हो गया? What is RG by RP? ठीक है. अभी क्या है? L constant है ना. So
constant है pi
rho G by
reaction
क्या बोला?
क्या होगा?
वो नहीं
और ऐसा होगा. तो अब देख लो रो जी कितना है? ये तो करना होगा. What is रो जी?
2.1 into 10 to the power minus 6
करके देखना पड़ेगा, ठीक है. और आर जी कितना है? आर कितना है?
1.5
1 हो जाएगा आर जी 1 हो जाएगा
और रो पी बताओ कितना है?
10.5
10.5 into 10 raised to power
माइनस. ये आर पी अपॉन आर जी उसका स्क्वायर करो
तो 25 by 1
तो कितना आएगा देखो.
25 centimeter by 1 centimeter तो सेंटीमीटर कट तो 25 by 1 25
ये कितना है?
25
So this is 25 to 25 आएगा.
10 raised to power 8 10 raised to power 8 कट 2.1 into 1 का 5
करके देखो ना.
5 आएगा सर
ये तो खत्म हो गया.
5 आएगा
So
और
both
सर
दोनों ही
2.1 and 2.1 into
both
5
नहीं वो करके देखो
सर
accurate
करके बताओ सर 2.1 into 5 10.5
1 आना चाहिए आंसर तब इक्वल होगा ना
हाँ तो 5 आ रहा है इक्वल नहीं है
इक्वल नहीं है ना तो wrong है फिर
सर A1 चेक कर
so
लीजिए
so basically both statements are incorrect to D तो ये क्या है
सर ये लास्ट
करके ही देखना पड़ेगा
सर आप सर्वर रेट के ऊपर आ गया है
13 का आंसर
मैं इतना बोर्ड
थोड़ा सा हाँ सर से सही आ रहा है
हाँ होता है
यस
तू और क्यों भी जा रहा है
सर मेरे को उल्टा गेट
नहीं डोंट रिलाई ऑन माइंड करके देखो थोड़ा सा टाइम ज्यादा लगेगा इसलिए ये एमसीक्यूज एंड में अटेम्प्ट करो क्योंकि कभी ये क्लिक हो गया तो फटाक से होता है अदरवाइज इट इज टाइम कंज्यूमिंग एंड नॉट लेस मार्क्स फर्स्ट कंप्लीट द पेपर व्हेन इन डाउट अटेम्प्ट एमसीक्यूज इन द एंड ओके चलो नाउ विल स्टार्ट
मेरा
सर एमसी के लास्ट में अटेम्प्ट करेंगे तो वो सेक्शन एक पूरा लास्ट में अटेम्प्ट करना पड़ेगा ना मेरा पहला सेक्शन भी
बोल रहे हैं सर
Question number
से आ गया भाई
अरे नहीं
स्पेस छोड़ देना शुरू में स्पेस छोड़ देना
सर
स्पेस नहीं छोड़ सकते
सर
क्या बोल रहे हैं
नहीं सर एमसी के साथ दूसरे कंपलसरी
स्पेस नहीं छोड़ सकते क्या
तो वही तो बोल रहा हूँ सरकाजम में बोल रहा हूँ स्पेस तो छोड़ ही नहीं सकते
अच्छा छोड़ सकते हैं वही तो
वो एमसी के साथ कंपलसरी कुछ होता है ना वो भी करना पड़ेगा ना अबे if we leave them there तो बस एमसीक्यू नहीं कर सकते
स्पेस छोड़ देना मेरी मां
अबे क्या बोलता है
मेरे वाले
अगर तो पहले
कुछ नहीं होता है कुछ नहीं होता है
तो सेक्रेटरी का लेवल वो कैरेक्टर के ऊपर ही रहता है क्रिटिकल मार्क्स है
Okay, let us start with scattering of light.
इसको आप जो है
Okay, I need your full attention. You come here. What's his name? Come here, sit. On the first bench. Fast, quick. आगे बैठो. So now what we are going to do is scattering of light. So any idea what is scattering of light? Is it covered in the school? It is covered in the school.
very
Syllabus तो cover हो गया तुम्हारा बहुत पहले. तो what is scattering of light? जो तुम्हारा understanding है.
सर टेक्निकल
तुम्हारा भी हो गया स्कूल में? बताओ anybody? You want to answer? Scattering of light.
so when white light goes through a prism and disperses into certain problems
Dispersion I'm not asking. I'm
So
asking.
kind of like if you pass a ray of light, rays of light parallel beams
Scattered.
through a concave
Scattered
lens.
means what is the English meaning of scattered?
Absorption
What does that mean?
सर वो जो पार्टिकल्स छोटे होते हैं
In English, what is the meaning of scattering? Scattered thoughts, random. Okay? Spread out. Like how you don't know how it is spreading out. Spreading out randomly. That is scattering. Have you heard of irregular reflection?
Yes.
What is irregular reflection?
Reflection through
when the reflector is very weak or something then light is
One at a time. Yes, he was trying to answer.
reflection through an uneven surface.
Yes. So reflection through a uneven surface. So what is the difference between a reflection through a plane surface and uneven
Plane
surface?
surface the light rays are which they are parallel
Bounce back from the same medium. Bounce back.
So this is an articulation issue. You know it, but not able to articulate it. Incident rays are in the same direction in both cases, whether the surface is plane or smooth. But the reflected rays are also parallel in case of smooth surface. In case of non-smooth surface, the reflected rays are in different direction. Right? So, like if it is a plane surface, The incident ray and the reflected ray are in the same direction. This kind of reflection is called regular. Correct? But what is the scattered? Let's say the surface is not plane. So now the incident rays are parallel. Okay, to each other. But what about the reflected ray? Now see, the normals will be different. It is a curved surface, right? On a curved surface, so this is the normal here. This is the normal here. Now this is the normal. Can you see? Now the reflected rays are in different directions. So this is irregular reflection. This is also sometimes called as diffuse reflection or scattering. Okay. So this is scattering, means reflected rays are in different directions. Now, it is saying absorb. Let us say you have a medium, some medium, right? So there is a particle of the medium. Now light rays are hitting it. Incident rays are being hit at different parts. Now what is the normal here? Along the radius. So this is incident, this is reflected. What is the normal here? So we are assuming the particle to be spherical. So where will be reflected ray? Here. What is the normal here? Here. So this is a. Can you see what is the direction of reflected ray in each direction? Depending upon where the ray is hitting, the light ray is scattered in all directions. ठीक है, समझ आए? तो ये तो हो गया random reflection of light. It's called scattering of light, and the one which scatters the light is called particle of the medium. Particles of the atmospheric medium. Particle of the atmospheric medium. Okay? So basically, Earth is surrounded by atmosphere, and atmosphere itself has various layers. Okay? So let us say when the sunlight enters the Earth's atmosphere. So what are the kind of particles here? You have air particles at the top, right? As you go down, you will have water vapors, and if it is cloud, it may be like water drops also, or water molecule itself. Molecules. Then you may have smoke, industrial smoke. Very close to the surface of Earth, you may have dust particles. So these are basically scatterers. Okay, when light enters atmosphere, it encounters all these particles at various layers. Right. Now the size of the particle increases as you go from top to bottom. Okay. The bigger particles lie close to the surface of Earth. Right? The lighter or the smaller particles are away from the surface of Earth. Now, there are certain rules that are followed. Now, you understood when the light hits the particle, this is now depending upon where it is hitting the particle. And we are assuming the particles are spherical. Okay, small particles are spherical. Right? So, scattering of light light depends on the size of the particle. Or scattering. Okay, scattering of light of wavelength lambda depends on the size of the particle. Okay, what does this statement mean? If the wavelength is small, then it can only be reflected by a smaller particle. A light of bigger wavelength cannot be scattered by a smaller particle. It will pass around it. You understand? If let's say this is a scatterer and the size of the light, like the wavelength is bigger than the size of the particle, it may just go around it. But if the wavelength is small, then it will be able to reflect it. You understand? So the size of the light is characterized by its wavelength. So either the size or color. So in terms of color, scattering of light, one is in terms of size, scattering of light is inversely proportional to 4th power of wavelength of light. Okay? So it will become very clear soon. So which color has more possibility of getting scattered? The shorter wavelength. The shorter wavelength. Yeah? If you increase this wavelength, scattering will be less. So whose wavelength is shortest? Blue side of the spectrum. That's why the most scattered light is blue. So both these conditions are suitable for blue light. Okay, smaller. So first light to be scattered is blue light or violet light, because most of the upper layer is full of smaller particles. So the blue light will begin to scatter first. Will the red color be scattered by air particle? No, because they are too small. So red color will navigate around it. They will not be able to scatter the red color. Size is big. So these dust particle, so red color will be able to travel the longest distance within the atmosphere, because it can't be scattered by smaller particles. Okay. Now these water, if it is condensed water vapor molecule, it will become a water droplet. So that will become a big size. So it will be able to, now if it is able to reflect red color also, therefore it will be able to reflect all the colors before, because this is big enough to reflect red, not only red, all others. So when all the colors are reflected, then it will appear as white light only. That's why clouds appear white. All 7 colors are reflected together in the same direction. Understood? So clouds appear white because they are scattered by water molecules, and they are big enough to scatter all the 7 colors simultaneously. It is absorbed. It's like absence of light is gray or dark.
All these colors.
So dark cloud or gray, so the gray scale will increase or decrease. So all the colors are not being able to pass. So absence of light is gray or dark, you can say. Dark gray is black. Black cloud to दिखता है क्या? Dark gray हो जाता है ना? Smoke also it will absorb. It will not let the light pass through it. You understand now? So these two rules apply for scattering. Now there is one more definition for scattering of light. It is absorbed and re-emitted as per your book definition. So it's like this. When it is absorbed by this molecule gets excited because it has absorbed energy, right? But it cannot remain in excited state. It has to come back to its equilibrium state. That time it will release energy. Okay? So when it is releasing, it releases it in random direction. it absorbed energy in this direction, but when it releases, you don't know which direction it will release. So the released energy is in random directions. So that is also one way of describing scattering. So because light is continuously falling, so it is continuously being absorbed and released. After absorption, the release is in random direction. So that also can be used to describe scattering of light. Understood? That way. It's like this. When, like at a home, when you're heating tawa for making chapatis. Tawa, what is it called? Hot iron plate. Right? So hot iron plate is getting heated from the bottom in this direction. But once the iron plate is hot, you can feel the heat from a distance. It radiates in all directions. You get it? The radiation is felt from a distance. But when you turn the knob of the gas, it is producing heat in vertical direction. And you won't feel the warmth that much. But when the hot iron plate is heated, now it is radiating in all directions because it has absorbed so much energy. Now it is radiating. Okay, so scattering is random. Is that clear? Now there are certain application of scattering of light. What is the first? Red color of sun at sunrise and sunset. So why do you see the sunrise and sunset as red? Now look here, let us say sunrise is taking place in the morning. So this is the sun here. Okay. So in the morning, the sunlight travels the longest distance through the atmosphere. Let's say AB. Sunlight travels longest distance through the atmosphere. So which color begins to scatter first?
Violet,
Violet, blue, everything, right? The last color to be scattered is red. So if there is an observer standing here, only he will feel that only red color is reaching him. So he will see sun as orangish red. But at the noon, so when the sunlight reaches, which length is big, this or this? This one is bigger, this is small. So at noon, because of the placement, right, the distance traveled by the light through the atmosphere is much less as compared to the distance in the morning or in the evening. So here there is not much chance of scattering for the blue color. Almost all the light color reaches simultaneously to the observer. So sun appears white. Okay, so it's like this. If I draw the diagram of a perfect circle, if the observer is here, so morning time the light is traveling longer distance through the atmosphere.
So the light bends,
What?
right? During the morning.
Huh?
In the morning, the light.
Yeah, but we are not showing the refraction. That's early sunrise and delayed sunset.
Ah.
So that is there, but the distance through the atmosphere is bigger in the morning than it is in the afternoon. So there's not enough chance for the scattering during afternoon. So sun appears white in the direction of sun. In the direction of sun, it appears red. But elsewhere, it appears, the sky appears blue. So sky is full of blue colored scattered light. Okay, because that color is scattered the maximum. These two conditions. Understood? Understood, everyone? Least scattered color is red color. So red color of sun at sunrise and sunset. Understood?
Yeah, one doubt.
Mm-hmm.
Sir, we are
Then why ask?
blue and indigo is like sky we can see.
Blue.
Right, blue. We can see the red also and orange also. So it's not green. Is there any circumstances to be there?
नहीं ऐसा तो नहीं होता क्या होता है ना कि if it is only blue then blue color is scattered but if the longer wavelength is scattered then blue is also mixed in that you understand mixture है वो like if it reaches the green color then green till blue is scattered so you will The dominating color, if it is on the left side, it will appear bluish to you. So whole thing coming from sun either appears bluish or reddish. That's it, because it's all mixed up. Okay. Why reddish? Because those colors are scattered away now. They are not now reaching the eyes. It's a dynamic thing. It is not static. Is that clear? Okay. Next, white color of sky at noon in towards the direction near sun. Okay, not elsewhere. Sky appears white at noon only in and around sun. Around sun. But if you take a bigger angle, sky is blue even at the afternoon. Isn't it? Even when there is a full bright sun above your head, elsewhere the sky is blue only. Near sun it appears white because that distance is less. Blue color of sky we explained because that is blue color scatters maximum. So that's why it is blue color of sky. Black color of sky in absence of atmosphere.
So there's no refraction.
Yeah.
There is no scattering.
Scattering.
You need scatterer to spread the light. So if you stand in space or on the surface of moon, which has no atmosphere, so any time of the day at Earth, you will see the sky around moon as above moon as black only. Like we see twinkling stars at night on Earth. On moon, 24 hours it is like that.
It will be so cool, right?
Has to be. Right? No atmosphere, so you will have to be loaded with oxygen cylinders and space suit.
You.
So white color of clouds, ये हो गया. So you have white color of sky at noon, then you also have white color of clouds. So sky is bigger than the wavelength of visible light. Aggregates of water molecules. I explained that already. Sixth, use of red light for the danger signal. Why do we use red color for danger signal?
Because it refracts the rays. So if the
It scatters the least.
yeah, it scatters the rays. So for example, if there is
So
a
can
fog,
be seen from the longest distance.
so if there is a fog, we can see that.
Can.
Cars light, car with light was it goes.
Car.
Red light. If there is too much fog, so light.
Then also red light is visible
Red light.
from a distance because it scatters less. Use the keywords. Listen, don't write stories. Okay, use the keywords. Scattering आना चाहिए उसमें. Less red color scatters the least. Simple. Okay. That's why it can be seen from longest distance.
Yeah.
All right. Similarly, remote control of electrical gadget like TV also make use of infrared radiation. ठीक है, remote control also uses infrared, which is just next to red color. So it is invisible. So at least longest distance will operate devices from a longer distance. ठीक है. So with this we are done with scattering. Do you have any questions? There are no numericals in this. So take a look at the spectrum chapter. Anybody has any doubts?
Some remotes use red color.
No.
Sir, our school का.
That is laser pointer, not remote. That is laser pointer to show thing on the slide. It's a pointer.
So infrared like rays red light.
Oh,
Laser. That is laser light, not remote. Laser right. ठीक है? It is called pointer. That's not remote.
You will fire it in each other's eyes.
Huh?
You will fire it in each other's eyes.
No, that's
That's very
dangerous. Don't stare at it for too long. Don't you have any questions? Nobody?
No.
Huh? You all missed one lecture. Good. So,
Testing it out most of the time. Radiation.
It's the most powerful.
so there are certain questions given in your volume.
X-ray होता है.
Microwave.
Microwaves.
तूने माइक्रोवेव
वो क्या होता है भाई?
अल्टीमेटली ओए मैंने तो इससे पूछा
मेरे को माइक्रोवेव से पता है.
हो गया?
होता है
माइक्रोवेव में फिर एक्सरे होते हैं.
Okay, I will start with now sound chapter.
नमूना
माइक्रोवेव्स
कमरे के बाहर माइक्रोवेव
है रेडियो
रेडियो वेव्स के बाहर
एक्सरे के बाद
बोल रहे हैं माइक्रोवेव नहीं बोल रहा है.
Uses microwave video के बाद
सर ये नहीं ये बोला था कि
मतलब in what order?
सर ये एक्सरे गामा रेज के बाद माइक्रोवेव फिर एक्सरे और गामा
इसका ऑर्डर ही नहीं है भाई गामा से
है
The
order.
most powerful है ऑर्डर.
गामा से माइक्रोवेव कौन सा ऑर्डर
गामा माइक्रोवेव
Right to left.
एक्सरे
क्या हो रहा है भाई?
पॉपुलर लेफ्ट टू राइट टू ट्रेवल नॉट एक्सट्रा हां एंड देन आता है
Right to
राइट टू लेफ्ट जब पहले फिर वो इसके बाद
रेडियो में तुमने क्या बोला?
तूने कुछ और
गामा बोला है
एक मिनट
मैंने बोला गामा के नीचे आता है.
एक मिनट मेरे क्वेश्चन क्या पूछा आपने व्हाट आर गामास
छोड़ दे छोड़
What are gamma rays?
सर इसको पूरा चैप्टर आधा है मैंने पूछा
So what are gamma rays?
चैप्टर में तुमने बोला.
Who would like to say?
चैप्टर
No, what are gamma rays?
most powerful rays in the spectrum they have the shortest wavelength
These are high energy radiations
That would be characteristic.
coming out by radioactive substance or cosmic rays. Okay, so most energetic radiation in the electromagnetic spectrum is gamma rays. Okay, let's begin with sound. So what is sound?
सेंसेशन ऑफ
उसके नीचे बोला भाई मैं उसके
What is sound? Okay, stop competing. What is sound? It is a form of
energy.
energy.
which produces
What does it let us do? Like
Here.
visible light lets us see things. So sound lets us hear. Okay. That enables hearing.
Hearing, finding out distances.
Okay. So this is the most basic, which is sound. Now we have to know how it is produced. How it is produced? Sound is produced by? It is produced by
Vibrating bodies.
vibrating bodies or objects. Or bodies. Okay. So production we have seen. Then
This is the form of sound waves.
production के बाद
Sir, वो
Propagation.
longitudinal wave as well as transverse wave.
how does it propagates?
In the form of waves.
Like I'm speaking, but you're listening to my sound at a distance. So I am the source producing sound through my vibrating vocal cords. But you're listening due to the vibration inside your ear,
Earlobes.
which is converted into electrical signal and sent to your brain for cognition of that. Okay? So, but what between us, between your eardrum and my vocal cord?
Yes.
Medium, air. So it is disturbing the air molecules, okay? And one air molecule is transferring the disturbance to the next one, and this to the next, and so on. So it is the disturbance traveling, not the air molecule from ear to your ear. Air molecule is only vibrating. Are you with me? What is happening to the air molecule? Let's say when I begin to speak, okay, the air molecules here. Look here. The air molecule here.
What is the function? Is it
I'm explaining something. The propagation of
sound?
sound wave. So here is the source of sound, and here is the detector. Source and detector. So what happens when I speak? Okay, initially these air molecules are still, imagine, for argument's sake. But when I speak, it will push this air molecule away. Okay, so it will come closer, and then they all will come closer.
Compression.
So what will form is compression.
Compression rarefaction.
Okay. Then when I'm not speaking, then what happens? It will pull back. So this molecule actually oscillates around its main position, the rest position. Okay. Likewise, this also retracts after some time. So when it is retracting, now the distance between them increases. So you will see in motion, sometimes they will come close with each other, sometimes they will go far away. Then the main position. So this kind of spread out. So that if you look at it in 3D, so it will be like this. Regions of different pressures will be created. High pressure and low pressure region. So this is compression, this is rarefaction. Compression, rarefaction. So sound wave propagates through the medium. Okay, by forming a series of, I'm not writing full, compression and rarefaction. A series of compression and rarefaction. During the sound propagation, the particles of the medium remain at their place. They only oscillate. They are not traveling. What is traveling? Just the disturbance. You understand? So disturbance is energy transfer. Like when the object is moving, it has kinetic and oscillator has a kinetic and potential energy. At the extreme point, potential, and in between it has kinetic and potential. This is what an oscillator has. So it is transferring the kinetic and potential to the next, to the next, to the next. That energy then gets transferred to the eardrum. This is how it is done. So is the air molecule also traveling? No. It is only passing the energy, the disturbance.
From one to the other. From one particle to the other.
Yes.
The energy is
And that disturbance we call wave. That disturbance we call wave. So what is traveling is the wave, the disturbance. Is that clear? Which is energy. So wave is a mode of transfer of energy. This is how you understand. Wave is a mode of transfer of. So wave is mode of transfer of energy. In this case, it is sound wave. Just like that, you have electromagnetic wave. That also transports energy only. But the energy is in the form of electric and magnetic field. Okay? And you know that one form of energy can be converted into other form. So that electromagnetic thing, like when I'm speaking in a mic, sound energy is converted into electrical energy. And it is then transmitted as an electrical or electromagnetic wave wirelessly. Over a long distance, it is picked by another receiver. Then the electrical energy is converted back into sound energy. Then we hear. This is how communication takes place over a long distance. Understood?
But then how can we hear ourselves?
No, the detector, no, you are speaking.
But how can we hear ourselves then?
You are hearing because sound is traveling in all directions.
Can go also.
Wave can travel in all directions. Here it is showing that it is traveling here, but it is traveling.
Can curve like this.
Yes,
To my ears.
obviously.
So does not travel.
Means when you're speaking, he is not able to listen to you. Disturbance is going everywhere. There's no preferred choice of direction by the wave. It will go in all possible directions. But for understanding's sake, we have taken one direction for simpler understanding. It's 3D wave. If somebody is hanging on the roof, will also be able to hear you. Okay? For the simplicity's sake, we are taking, but we are taking one line portion for understanding. Okay. So is that clear? Now this speed will obey the same formula.
So how does sound pass through a medium?
By forming compression and rarefactions. In a gaseous medium.
Opaque, like a door.
So it can travel through solid, liquid, gaseous, all medium.
So
For that,
someone shouts under water.
yeah. So it depends on the elastic properties of the medium. See, every medium is characterized by its elastic and inertial properties. Okay. That will come in higher standard. They have given you so much of things, but those are very fundamental.
So the world's quietest room has wedges. Has wedges. The world's quietest room, like it absorbs
what?
wedges. It has wedges.
Wedges, nahi, edges. Edge.
Like wedges. It's like this conical ऐसा होता है बस taking out.
What?
The world's quietest room.
पूरे walls पर ऐसे wedges जैसे ही
wedges जैसा होता है ना पूरा walls. तो ऐसा होता है सर.
किस पे?
World's quietest room है. The quietest. Walls पे.
हाँ, walls पे क्या?
Wedges होते हैं.
मतलब you mean when you microscopically see it?
So the very can see Google sir, it's like wedges. So it's a बड़ा diagram. So there ऐसा room है, and this entire room is on springs. और इसके roof, इसके walls में ऐसा हर एक पूरे इस पे
मतलब कहाँ पे ये स्पेशली डिजाइन वॉल है?
स्पेशली डिजाइंड है ये रूम पूरा तो absorb it's like the quietest room.
अच्छा ओके ऐसा बोलना. So there are different ways to create a room which will absorb sound. That is basically to avoid reflection. नहीं तो तुम्हें echo सुनाई देगा. Reverberation will take place if the hall is very big. That's why if you go to cinema hall also, you will see the wall has got sound absorbent porous material. So it absorbs the sound. It does not reflect. Hard surface will reflect it back. So you're getting into very different aspects. First, stick to the basics. What are we discussing here? We are discussing what is sound, how it is created. It is created by vibrating objects, right? How it propagates. It propagates in the form of waves. Now, waves are also different types: longitudinal and transverse. So, what is longitudinal and transverse? Now, look here. How the molecules are oscillating of the medium parallel to the direction of propagation of waves or the disturbance. So, this kind of propagation is called longitudinal. The disturbance and the molecule oscillate parallel to each other. This is called longitudinal, along the length, longitudinal. Okay. When the molecules oscillate perpendicular like this to the propagation of disturbance or the wave, like on water surface. If you drop a stone, so how the ripple spreads? Ripple spreads like this. But how is the water molecule oscillating? Up and down. This kind of disturbance is called ripple is going outwards only, but the molecules is going up and down vertically. That is transverse across. So that kind of wave propagation is called transverse. So in sound, when you plug the string of a musical instrument, how are you plugging? Up and down. And the vibration is traveling horizontally. Understood? So that is, the vibration is transverse here. Okay? When you are producing sound wave on a solid medium, the vibrations are transverse. Okay, whereas in the gaseous medium the vibrations are longitudinal. Is that clear? Now the speed is given differently. Speed of sound wave in the gaseous medium is given by this formula. Speed of sound in gaseous medium is given by what is the formula? E by D or rho. So what is E? E is elasticity or modulus of elasticity. What is the meaning of elasticity? When do we say the object is elastic? When you
can stretch it.
see, when you apply force, its shape is deformed like a rubber. But when you remove the external force, it regains its original shape. So, like a water medium, when you put a stone, right, its shape is disturbed. But after a while, it regains its original shape. Correct? Spring also.
So what's the unit for it?
Elasticity.
Was it
Elasticity. नहीं, उसका it is a constant basically. So Newton per meter square.
ज़्यादा stretch कर देंगे तो it tends to hold that stretch form क्योंकि ज़्यादा stretch करके इसके लिए.
देखो, the unit for it will be, listen, square of velocity times density.
Square of velocity
Times density.
into density.
Substitute the units, you can figure it out. Derived units. Okay. So what I'm trying to say is, if the medium is elastic, sound wave will propagate easily, isn't it? If the medium is elastic, this propagation will be smooth and fast. So velocity is directly proportional to the elasticity. The more it regains its shape easily, speed will be faster. So it is, speed of sound is directly proportional to the elastic property of the medium, whereas it is inversely proportional to the density of the medium. If it is more dense, then the movement will be obstructed. Okay? So this is how the formula is given, right? So for all mediums, so for gaseous medium, what it will become? For gaseous medium, and rho is density. So propagation of sound will depend on the elastic properties and density of the medium. Okay? So for gaseous medium, there is a different formula.
This is for liquid and solids.
All medium. Now this will get modified into different.
For gaseous.
This is the general formula. Velocity will be directly proportional to the elastic property or the elastic behavior of the medium, inversely to the density. For gaseous medium, this gets transformed into
Which is
P, pressure of the medium versus pressure upon density. Gaseous medium में क्या हो जाता है? Pressure, and more refined it becomes gamma P. Okay, gamma P by rho.
So nature letter D है ना?
Rho है, वही density D दिया है कि rho दिया है?
D है sir.
rho and d.
Capital D दिया ना, ठीक है, चलो
The
density.
small d.
कहीं पे small d है, कहीं पे capital D है, कहीं पे rho है. So you just read what is the distance. समझ में आया? D is the density. वॉल्यूम में कुछ और दिया है, बुक में कुछ और दिया है। So बुक में क्या दिया है? स्मॉल डी दिया है।
Doesn't matter.
It does not matter. So यहाँ पे डेंसिटी है, ठीक है? यहाँ स्मॉल डी लिख लो चलो। ठीक है? तो जो E है, that becomes pressure. ठीक? And gamma is called specific of ratio of specific heat capacities. There are two specific heat capacities that you will understand in the last heat chapter. वहाँ पे मालूम पड़ेगा, ठीक है? So when gamma is equal to Cp by Ce, and for air it is 1.4. ठीक है? तो ये न्यूटन ने formula दिया था P by D, which was wrong. It was giving wrong value of speed of sound. Then Laplace give the correction. So all of this you have done in 9th standard. If you have learned about it, then this gamma was given by Laplace. Before this, it was P by D. Okay. So all these things you are going to study later.
Newton did not understand कि मैं इसको substitute कर दूं गलत आ रहा है.
This is how science evolves. Like for hundreds of years, you studied the wrong concept. Like Aristotle's understanding about force and motion was flawed.
So we are doing.
Till Galileo gave the correct explanation. Okay, Aristotle, as for Aristotle,
How did we know that he gave the right explanation?
that's what now the modern science is based. There's science before Galileo, science after Galileo. Newton framed his laws followed by Galileo's law.
Science after Galileo is modern science.
वैसे तो क्लासिकल न्यूटन को ही हम क्लासिकल बोलते हैं आफ्टर आइंस्टाइन साइंस. There are various demarcation in the history, right? So there'll be in your family time after your life and time before you, like that. These are historical perspective. Are you understanding? So this is the formula for velocity of light in the speed of sound in the gaseous medium. One is the basic formula for speed. This is in general for wave, and this is specifically for velocity of sound in a gaseous medium, where P is the pressure. This is ratio of specific heats at constant pressure at constant volume. These are different. Okay. Then you have speed in the solid medium. In solid medium, like in the musical string instrument. In solid medium, what is the velocity of speed? It is given as tension upon m.
M is
Mass per unit length. Now here m is not mass. So right now P is mass per unit length. Mass of the string per unit length. Understood? K is mass per unit length. So let's say you have a string, okay, string of musical strength of length L. Look here. So how the speed is given? T by M. But what is the formula for speed? V is equal to F lambda. So basically, you can write, since V is equal to F lambda, what is the frequency? Frequency is V by lambda. Frequency is V by lambda. Now if you plug the string like this, so it will begin to vibrate like this. Correct? This is the smallest frequency possible. If you plug it in the middle, you will have one loop. Has he slept? Hello?
So then that's what
Now this is half wavelength, right? So what is L? Huh? So lambda is equal to, what is the relation between lambda and L? Let's say this is the wavelength. This will be lambda by 2. Correct? So lambda can be written as 2L. Lambda can be written as 2L. And then this can be written as 1 by 2L root P by M, which is capital M. So what is M now? But M is equal to what? Capital M by L. What is mass in terms of volume and density? Volume into density. And what is volume? Area of cross section. That is, what is volume? Area into length into density. So then this cancelled. Volume is area into length. Area of cross section of the string, right? That is A. Understood? So A into L is volume V. So what is AD? AD is pi r square d. So that's how this formula you get. 1 upon 2L T upon pi r square d. Somewhere in your book this formula will be given. So you will find this formula ahead. So I have given you all the formulas at one place. Okay. Is the basis of this formula understood? Not by you. Because you don't write. Everybody understood how we got this formula? It is maybe in the next section. So today we have covered all the basics of sound chapter. So do you have any queries here? So with this background, we'll be starting about reflection of sound. So in this chapter, the main thing is reflection of sound. But till this formula you should write. Okay, then the next discussion will be easy because this chapter and the chapter before are very heavy chapters conceptually. If you have understood this, the next topic will be easy to follow because now I will be referring directly to these formulas. Okay. Do we have some time?
So you have 30 seconds.
Only.
Yes, sir.
Okay, so reflection of sound I will start in the next class.
Right segment is this.
हाँ?
ये दोनों मत मिस करना.
नहीं बस ये वाला कर देता हूँ.
So it's right now.
हाँ? Done. Doing now. I mean, if you can wait for 2 minutes, I can.
So basically reflection of sound क्या है? Light is
Light is
of sound after striking arts.
Only thing is the size of the reflector has to be equal to the wavelength of sound wave. And what is this wavelength of sound? From 1 centimeter to 10 meter. It's much bigger than the wavelength of light.
उससे ज़्यादा नहीं हो सकता. इसका भी नहीं हो सकता.
मतलब ये रेंज है. ज़्यादा या कम हो सकता है कि नहीं वो देखना पड़ेगा. जो तुम्हारे
displacement of the particle.
No, the wavelength of the sound wave. Wavelength of the sound wave is 10 meter on the bigger side. Smaller side it is 1 centimeter. ठीक है? So 1 centimeter मतलब light से तो बहुत बड़ा हो गया. So you require a big obstacle.
नहीं light के अंदर ही आता है.
नहीं.
वीडियो में नहीं सॉरी
एंगस्ट्रॉम में होता है यार 10⁻⁻10 होता है लाइट. और ये क्या हो गया मीटर में. So here the reflector of sound wave has to be a big obstacle, like the walls. Light can be reflected by very small size, but sound reflect करने के लिए you require bigger surface. ठीक है? ठीक है चलो you guys are like बाद में होता है. So all the students class very fragmented. Understood what we did.
थोड़ा complex.
थोड़ा है थोड़ा पढ़ के ना.
जो concept है वो कौन से लग तो 16 तो समझने को क्या
नहीं वो वीडियो देख रहा है.
फिर भी क्या फिर उसने एग्जाम क्या बोल रहा है यार क्वेश्चन को सही करना समझते हो पूरा
लगा सोना तो क्या हेलो
पूरा सब चीज से बहुत सही गाना याद है जब मैं छोटा था कोई चीज नहीं समझ रहा अरे वो यार क्या था वो उस पे गाना था अरे यार बहुत इम्पोर्टेंट गाना है यार वो मुझे सुनने जब मैं छोटा था मैं उसको
मुझे तो दूर से देख रहा है. पेज 190 पेज 190 में जूलियस सीजर है.
देख क्या था
पेज 190 में जूलियस सीजर है.
अबे लोग भाई में इम्पोर्टेंट गाना है उसमें
हां
अबे बादल पे था सड़क के खाली वाला था, सड़क खाली है।
तो मैं ऑप्शन ली
तो मतलब ब्लैक कौन ये होगा?
190 के पास
190
190 और 119
अरे
पहले मैं नहीं पढ़ता वैसे
ये सी
तो फिर कोई नहीं है।
नहीं दूसरी है
अरे यार वो कौन सा गाना था यार?
ये देखिए
और
ये
माइनस
क्या आ रहा है
ये
बुरे से लगाया
दैट
क्या
कौन सा चैप्टर है?
सूरज के धनुष के पीछे
सूरज की या
दो
अबे यार कैसे गाना है?
दो
ओ राघव भाई कैसा है?
ओ भाई कैसा है गुड
ना
गुड राइट
और राघव भाई ये तो पता कैसा है?